Hello, Algebra 2 students. It is day 3 of our quadratics unit, and we are going to be talking about more factoring, this time specifically. When we say the leading coefficient isn't equal to 1, that means the leading coefficient is like 2 or 3 or whatever. So 2x squared, 3x squared, you get the deal. All right, before we do that, let's do some quick practice with some stuff that we already know. So for each one of these, directions are to just simply factor, all right? So the first one here, I'm going to go 8x cubed minus 125, and then I'm going to put a second one over here. But the directions for the second one is going to be to multiply. All right, so consider the directions for the first one, factor, second one, multiply out, and that is going to be x plus 3 and then times x minus 7. Right. Feel free to hit pause on the video really quick, try them out yourself, because it is important that you know how to do this. We will have a quiz on all this coming up in the next week. Right? So what I'd want you to look at is when you know the different types of factoring on this first one here. GCF, there is no common factor between 8 and 125. Difference of perfect squares is what it might present as, but that is not a perfect square because of the exponent of 3. So difference of cubes should be what comes to mind here. So for difference of cubes, you have to take the cube root of each piece of it. So the cube root of 8x cubed and the cube root of 125. In this case, the cube root of 8 is going to be 2 of x cubed would be x. The cube root of 125 is then 5. Because it's subtraction, we keep the minus sign in the first parenthesis, which means when I go to the second parenthesis, I'm going to have plus and plus. All right, it's the first term squared, so 2x, that quantity, squared. The product of the two, so 2x and then times 5. And then the last term squared. And then, of course, we can clean that on up a little bit. So 2x minus 5 in the first parenthesis. This turns into 4x squared plus 10x and then plus 25. So that should be the final answer for that being factored down. All right, the second one, just multiplying out, no tricks here. You can FOIL if you're familiar with FOIL, otherwise a little box multiplication. In terms of foiling, in case you're like, what is she talking about? First, outside, inside, last. So you multiply the first part. So x times x would give me x squared. You multiply the outside pieces. And so x times negative 7 would give me minus 7x. The inside is the inner two pieces here. That would be the 3 and the x. And then the last in each parenthesis, that would be the 3 and the negative 7. So minus 21 like that. So here's the first, the outside, the inside, and the last. And then when you clean it up, you would get minus 4x and then minus 21. If you see it and you're like, I prefer the box multiplication, then use box multiplication. But either one will get you the same answer. Right? The reason we do that is because that's going to be a skill we have to practice for today. So when we talk about being able to do basic trinomial factoring, so if I said, all right, let's factor a basic old trinomial like x squared minus 4x minus 21, we've gotten in the habit of saying, all right, well, we know we need a number that adds to the middle term, multiplies to the last one. And you might recognize that answer from right up here, but it's the idea that when we stop and think, we think of factors of 21 and we say, okay, well, 1 times 21 or 3 and 7. This one's pretty simple. There's not too many options. So it would go x and x, 3 and 7, and then because of our signs, minus and there, and then plus here. All right. The reason I bring that up is that when we go to factor these ones with a leading coefficient that's not equal to 1, that's only part of the game. So it's going to be important that we can look at these factors, but then also some more. So what I mean by that, let's give ourselves an example to work with. If I give you one where I give you 5x squared minus 14x plus 8. There's going to be two ways that we can handle a question like this. The first way, I'm going to call it method number 1, is going to be to actually do a little guess and check. All right, that's the first way that I'm going to think about this. All right, so how I want you to think of this is how it kind of breaks back down. So a couple of things. Just like we did the last one, I can start with the 8, and I can come on over to the side and say, okay, well, 8 is going to break into either 8 times 1 or 4 times 2. Those are the only factors we really have to think about. But in the case of the leading term, the 5x squared, we have to consider like what would give us that, because it's not just x and x this time. So I actually like taking the box method approach to be able to kind of visualize what's happening here. So I'm going to give myself the box to work with. And what I want you to think of is that whatever goes here and here gives me that first term of the 5x squared. Whatever goes here and here will give me that last term of the 8. So we've already kind of broken down and figured out what 8 could be. But for 5x squared, instead of it just being x and x, the easiest way to do this would be to make it 5x and 1x. Nice thing about 5 is that it's prime. We'll talk about some when they're not prime and what that looks like. All right, but let's break it down to start there. So this is going to be 5x and 1x. Now over here, we said it's either 8 and 1 or 4 and 2. What you really have to think about, though, is we need to make sure that the right things are getting multiplied together so that when we add up this diagonal, it's coming out to equal that middle term of negative 14x. Well, depending on what I put up top here, it will get multiplied by the 5. Depending on what I put down here, it gets multiplied by the 1. So I really actually have to think about the order in which I place them or where I place them. So I can think of it as 8 and 1, but I might have to think of it as 1 and 8. And same thing, 4 and 2, I might have to think of as 2 and 4, depending on where I place them here, right? Because the order or the placement matters. All right, with that being said, we're going to do this kind of drawn out like this, just one time. So stay with me. The 4 cases that we would have to look at here would be each one of them would have the 5x squared and the 8 in there. Whoops, I might have spaced these out a little bit too much. We'll make this fit. Let me see if I can squeeze one last guy in over here. Yeah, we can make that work. Okay, so what I mean by that, put the 5x squared and the 8 in every single box here. All right, what we're going to keep consistent is what we did up above. We're going to keep the 5x on the left, the 1x on top. So 5x, 1x, 5x, 1x. It's a fun game. All right. What can now change around is what goes in the latter part. So it either has to be 8 and 1. So maybe we can go 8 and then 1. Or it could be 4 and 2. Or flip-flop the locations. Go back to 8 and 1, but put the 8 on the top and the 1 down here. And then go back to 4 and 2, but put the 4 on the top and the 2 down here. All right. By doing this, what we have to remember, right, is that depending on how this all multiplies out, we're going to get different values along that diagonal. So if we actually go through and kind of try this first one out. So 5x times 1, that would give me 5x. And then 1 times 8, that would give me 8x. Right here, if I add those two together, that's going to give me 13x. And what I'm looking for is for it to come out as 14x. So that one doesn't work, right? And then you can work your way through it. If we do this next one, 5 times 2, we would get 10x. 1 times 4, that gives me 4x. And this looks like it's our winner right here. Now, just to convince you, if I go through 5 times 8, that would give me 40x. 1 times 1, this one would give me 41x or maybe 39x, depending on if I add or subtract. But either way, it's not going to give me 14. So we can see that that one doesn't work. And then the last one, 5 times 4 would give me 20. 1 times 2 together, that's going to give me either 22, or maybe if I subtracted, that would give me 18. But either way, neither of those are going to work. So this one is definitely our winner right here. What does that mean in terms of the actual answer? Well, the answer is in one parenthesis, we've got 5x and 4. In the other parenthesis, we've got 1x and 2. And now you have to think about the signs. We want them to actually add up to negative 14 here instead of positive 14. But they are going to multiply to give you a positive 8. So double negative should do the trick. If that's negative, that would make this negative. That would make this guy negative, which adds to my negative 14. But then negative negative would still be positive 8. We're good to go. So here is my answer. All right. There is nothing wrong with doing it this way, but it can become a little obnoxious depending on how many factors that second value has, or maybe even how many factors that first value has. 5x was great because it was prime. If this first term had been like a 15x squared, and then this was an 8, now you have even more options you have to look at. So that's why we have method number 2 to talk about. So I'm going to flip on over to another piece of paper here. And let's take a look at what method 2 is. Oops. Just getting my notes all organized next to me here. All right. Just kidding. Try that again. Okay, here we go. So method 2. Some of you might know it as slip and slide. I'm not going to lie. I never actually remember what the name fully is, but if we kind of talk about all the pieces of it, we're going to kind of call it a slip, factor, divide, and then slide. Now you can call it whatever you like. You don't actually have to know that full out name, but let's take that same example and see if we can run it again. So it was 5x squared minus 14x plus 8. So some of you right now might be thinking like, yeah, I kind of remember this. Like we did something like this back at, Minerva DeLand. I'm going to attempt to write the steps down as we go. So step number 1, to be able to do this, that slip step means that you're going to multiply that leading coefficient by the last term here. All right. So multiply the leading coefficient by the last term. So 5 times 8, that's going to give us 40. So I'm going to take that as x squared minus 14x and now plus 40. That's what I end up with here. All right. The whole point of doing this is so you can factor a nice, easy trinomial that doesn't have a leading coefficient. So now factor the trinomial. And I only put that in quotes because that's the factor piece of it. All right. So this is a basic old add multiply right here. And so if we think about what multiplies to 40, adds to 14, that's going to be 10 and 4 because it's double negative to get us a positive here, but add to a negative there. We're going to make that minus minus. All right, step 3, that is the divide step. So we have to bring back in that leading coefficient of 5. So we're going to divide the constants by the leading coefficient. So in this case, just to make sure that we are clear, that is the 5 out front right there. And so divide this by 5, divide this by 5. And now, I don't list it in the title here, but when you do divide, make sure that we simplify. So before we get to that slide step, simplify the values. All right. So we'll say, simplify this, that becomes x minus 2. 4/5 is a simplified fraction, so we're good to go. And then the last part of it, the slide piece. We're going to slide any denominators back in front to be the coefficients. All right. So we'll slide the denominator right in front of x. So the denominator here is just a 1. There's nothing. But the denominator here, that is going to slide back in front. So now this is x minus 2, and then this is times 5x minus 4. Okay. The only way that I allow you to use this method, because I don't mind this method, it's a little easier to use than maybe just guessing and checking your way there, is if you check the final answer. So here's the key. To check it, I want you to multiply it back out. So FOIL or box multiply the answer back out. So now that we've talked about foiling, you can use FOIL or you could use the box multiplication. Like I said, it does not matter to me, but I want to see the work. Don't just be like, yeah, I did it. Nope, you have to show it if you want to get credit for a factoring question done with this method. Oops, let me just slide my papers up there. So with that being said, 5x squared minus 4x, there's the minus 10x plus 8. That's going to give us the minus 14x, and we are good to go. So there's our answer. Now, why do I make you check your answer? Because if I don't, people always forget the divide step, and then they just factor something and leave it completely incorrect, right? Not trying to throw blame at you, just telling you what happens. So let's move on and do a second example where if you prefer the guess and check, absolutely, you guys, you can try it that way. I'm going to show it with the slip divide slide or whatever the name is up there, just because typically the majority of my students prefer that method, and I'm okay with it. All right. All right, so let's try it out. If we run through those steps, the slip step. Slip is to multiply that 3 on over. So that's going to give us x squared plus 19x. And then 4 times 3 is 12. So that's going to be minus 120. Now you need to factor that guy. All right, it might not be super obvious. As a reminder, ways that you can, factor large values, go into your calculator, and anything you're trying to factor, type it in and divide it by x. So if I go into my y equals and get rid of whatever I've got here, if I go 120 and then divided by x and then go to the table, 1 times, you can zoom in a little bit there, 1 times 120, 2 times 60, 3 times 40. I'm looking for something that has a sum or difference of 19. So 6 and 20, no, oh, did I just go past it? Right there. So 5 and then 24 right there. So 5 times 24 will do it. Okay, let me zoom back out. So let's finish it off. So 5 here, 24 here. Think about your signs. I want it to add up to a positive 19, so plus 24 minus 5. All right, so that is the factor step. Now divide. So divide by that leading coefficient, which was a 3 here. So divide by 3, divide by 3. That's going to give me x minus 5/3. This gives me x plus 8. And now we can slide the 3 back in front. So 3x minus 5, x plus 8 here. And then lastly, just check this baby on out. For those of you that want to see that FOIL step again, I'll do it that way this time. So first, 3x times x gives me 3x squared. Outside, 3x times 8 is plus 24x. Inside, minus 5x. Last, minus 40. And then right here, that's going to give me that 19x. We are golden. All right, let's do one last one. So if we slide it on up, this one, I'm going to use 40x squared minus 22x minus 84. Oh, good and messy one here. Okay, something to keep in mind before you just immediately slip on over. Don't forget, whenever there's a leading term out front, it could be that you just have a GCF. So I'm going to write you that little note to look for a GCF first, because if you don't take a GCF out and do the slip, slide, factor, divide, whatever the heck it's called method, you will kind of lose the GCF and end up with a final answer that doesn't make sense. All right. So in this case, if you look at all those coefficients, they're all divisible by 2. So I can take a 2 out and make this 20x squared minus 11x minus, what would that be, 42. Now you can slip, slide, blah, blah, blah. All right. So I'll kind of go dot, dot, dot. All right. Let's try it. Keep the 2 out front. Just don't lose it. Don't forget about it. 20 times 42. All right. Well, you're going to be doubling 42 and add a 0. So 20 times 42 should be 840. So x squared minus 11x minus 840. Holy cannoli. All right, grab your calculator. Into that y equals, if we go 840 divided by x, and then we're looking for a difference of 11. Let's see if I can zoom in a bit here. So in your table, might have to go down a little ways. Let's see, we're getting closer. Oops, difference of, that's 22, difference of 19. Oh, there we go, 24 and 35. All right, so don't give up hope. That method works pretty darn well. Looking for it in here. So 24 and 35. All right, so x and x, 24, 35. We want it to add to a negative, so I'm going to make the larger number negative, smaller number positive. All right, and then let's finish it out. The leading coefficient now was the 20, so it's whatever number you slipped on over. So divide by 20. Here's one where, remember we said simplify? Super important. If you need to, so let me show it on my calculator. If you need to, you can do 24 divided by 20 and then math frac that. That's going to give us right here 6/5. So you do have to reduce this down first. And then same thing over here, 35 over 20. And then math frac it, 7/4. Okay, now you can slide those back up front. So 2 and then times 5x plus 6 and then 4x minus 7. Now, I'm going to box it in, but to check this guy out, take a second, come on over here. You'd have 5x plus 6. You'd have 4x minus 7 and multiply your way through. So there's the 20x squared minus 35x plus 24x and then minus 42. That's going to give us right here the minus 11 that we wanted. So when we take 20x squared minus 11x minus 42, that gets me back to this line right here. And then don't forget you'd have the 2 that would distribute all the way out and we'd be good to go. All right. Thanks so much for watching, guys. Go answer that post video question and I'll see you soon.